Hi there, welcome back. Right, we've determined in the last video that this thing actually has the transformer providing the B+, the transformer, the rectifier, and the filter capacitors. What we've found is that this point here, that's the B+ itself, which goes into the output transformer, is actually showing a 312 or 312 volts DC. So far so good. Now this is only the beginning. Now the next stage is to see whether all the B+ are going to where they're supposed to go. Now when I say all the B+, there's actually two B+, and the way this works is you've got your B+ over here. This is the first one that we've just checked. All right, over there's B+, that's the 312 volts. That comes out of the selenium rectifier, goes up here. If we follow that line over there, and we carry on, it goes into the output transformer, and that's that point that you see that I showed you on the transformer itself. We've established that it goes from there to the anode of the output valve, the power valve, EL84. We now have to check, and I have checked, that it comes from this point through this resistor, 1K resistor, to this point, which in fact is that second capacitor over there. Found that that 1K resistor was working just fine, and it was measuring just fine. So we have this point over here. Now what we need to do is to establish whether every point that gets this supply from this point over here is showing true. And the way to do that is you literally, let's go back a bit, you follow this line here, and we go up, and the first node where you can see it is over here. So the first thing we need to do is to make sure that it is getting to that point there, which we have done. Now that's pin 9 of the output tube. So we know that pin 9 of the output tube is a reference point for B+2. Let's call it the second B+. And we can connect our multimeter, our ohmmeter, on here, or anywhere on that point there. I mean, you can actually go under the chassis and connect it to the second capacitor, as we've established here. But it's actually easier to find a point accessible from the top of the chassis. And so far, the easiest point that I can find is pin 9 of this EL84. And so what we're going to do is we're going to call that B+2 or B2+. And we're going to measure where it goes to. We're going to check where it goes to. Now, if we take this line here, this node over here, and we follow it that way, it goes up there through a 100K resistor, up there through a 220K resistor, up there. Now, it can't go that way or that way because the capacitors block it. Remember, we're talking about DC. So it has to turn left, and it goes there. Can't go down because that's a capacitor and this is DC. So it goes through a 33K resistor over here, and it goes to the anode of the EABC80, right? So what we have is, we've got from that node, we add up these resistances. We have 100K plus 220K plus 33, that's 363K to the anode of that resistor. Now let's see what we actually get. So we're going from pin 9 of the EL84. That is, from the top you read counterclockwise, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same applies to the ABC80. It's also pin 9. And what do we get? 357.7, so 358K. That is near as damn it. So that line is fine. And that means that we can now paint this connection over here from there to there, through that resistor, that's fine, through that resistor, that's fine, through that resistor, which is also fine, and we're done to there. So what do we do next? Well, we have to follow that node. So we go back to here, and the next point on that node is that point over there. So where does this go now? Well, it goes to the switch. And what is this switch? Well, it is a bit difficult to see, but it looks like L8 and 9, L9 and L8. Now, fortunately, these guys make it easier for us because they tell us this is the switch graphic. ONML, there's L over here. It's on the pickup switch when you activate the pickup switch. And these drawings here give you the unactivated status. When they draw this, it's with TA or with pickup not selected. Now 8 and 9, there's 8 and 9, there's 8 and 9. It shows us here as normally closed, which means that when we don't activate our pickup, that switch is made, it's closed. When we activate the pickup, that breaks there and it makes between 7 and 8. In other words, it just breaks the connection. And the reason for that is that when you activate the pickup, you break the supply to the radio circuits. So if you activate pickup, that supply is broken there, and it means that your beep 2 plus doesn't go anywhere from here. It does, however, still go to the anode of the EABC 80, in other words to the preamp tube, which means that this preamp is working, and of course the power amp tube is working. And why is that working? Well, at this point it's only taking from here, where is it? From here, your pickup input, which goes in here, through there, through some tone controls, and into your grid of the preamp. In other words, at that point, it's only amplifying the pickup input. So that's just to make the whole thing a bit quieter when you're not using radio. So from that point, we want to measure to there. And that's the first node. And we can go to the switch or we can go up. Let's choose up. If we choose up, it takes us to the magic eye, to the anodes of the magic eye. And it also takes us one step further. We carry on going up here, and it takes us to this point. Now this point has a few deviations which we can measure. And the first one is, if we go to the right here, you follow from there to there, it goes through this resistor which looks like 2.2K on the circuit. It goes up to there. It goes up to here. It can't go through the capacitor, but it can go through that winding of that IF transformer. That's a DC low resistance, so it goes through there, to there, to there, through that winding, to there, and to the anode of the EF89. So we have another line to the anode of the EF89, which should measure from there to there, to there, to there, low resistance here, very low resistance here, so very low resistance so far. It gets to here and it's got a 2.2K to that point. And the resistance between there and that point is theoretically 0. So what we should measure is a very low or no resistance to that point over here, and a little bit more than 2K to that point over there. And if we go back to here, we've got that resistor over here as well, 47K. So we should measure from there through there to the second grid of the EF89, we should measure about 47K. And if we follow that line that way, we go this way, up there through a 2.2K, up there, up there. It can't go there because there's a cap, so it can go through this coil, through that coil, and there's actually a short circuit here. Between that coil can be short circuited depending on whether you're choosing FM or AM. I'm sure that B2 and 3 has got something to do with FM selector, but it doesn't matter, it's still low resistance. Through there to the anode of that first part of the ECH81. So there we should measure low resistance through there, 2.2K, about 2.2K. But it also goes one step further. It goes to there, through a 39K, and it goes to the second and fourth grids. Yeah, second and fourth grids of the ECH81. So we should measure about 39K to there. So we can do quite a few measurements here. Let's have a quick look and see what we get. Ah, 10 ohms. That's just probably lead resistance and wire resistance. So that's fine. So to the anode, which is pin 7 of the EF89, we should have 2.2K. We have 2.22K. Brilliant. To the grid, second grid of the EF89, which is pin 8, we should have 47, what is it? 47K, we've got 48K, brilliant. What's the other one? It's the ECH81 and it's the anode of the, what is it, first section. So it's pin 6. And we should have 2.2K and we've got 2.26K. Brilliant. The next one is to the second and fourth grids of the CH81, and that is 39. We've got 38 point. Damn it, this is close. Fantastic. All right. And the next one, there's one more we can do, isn't there? No, that's it. That's it. All right, that line's been checked. Let's see what the result is on the drawing. So on the drawing, what we've got is, we've got from this point through that switch, which we've determined is closed, to there, and to there, which we measured about 11 ohms. Now, considering dirty switches and so on, bad connections with the multimeter probe, that's fine. That's like a short circuit. Then we take this from here to that node point over there. And this is when it starts getting interesting. We checked from there to there through that resistor, 2.2K, which we measured as around that. Through there, it's going through the coil, to there, up there. It's definitely getting through this, or we wouldn't measure this resistance. And the resistance we got was just above 2.2K, which is perfectly correct. 2.2 plus small resistance gets you to there. So that line is fine. We also measured, what was it, 48 up through this one to there, 48. So that's fine. We also measured from here to here through that 2.2K, through that coil, to the anode over there. That is measuring fine, and we also measured near as damn it 39K from there to there. So you see, as far as B plus is concerned, B2 plus, that line is done. Now we have from here moving backwards into the front end. And where does this go? Well, this goes from here through a switch, which is B... Damn, I can't read that. B789. Now, what is B789? B is UW. In other words, it is FM. 789 are these over here. Now when FM is not selected, 8 and 9 are made or closed. When FM is selected, 7 and 8 are closed. Okay, so that's it's going to activate or deactivate the supply to the tubes depending on whether you have FM or AM selected. Now why would it do that? Well, let's have a look over here. This here is the FM front end. So if you have FM selected, that switch is made and power comes from there to there, through there, into the FM box. That resistor over here is that one that we saw had seen quite a bit of heat. I'm wondering if it's alive or not. We'll check now. So that should be 2.2K. Okay. If we've got AM selected, then the supply goes up here, up there, through 33K, through there, and up to this anode here on the ECH81. And that is the only point that we need to check. Okay, perfect. Let's have a quick look. So we're looking for the anode of the triode in the ECH81, and that is pin 8. And we should have 33K. Brilliant. 32.5. Now if I choose FM on the front, that should go to overload. Yep. Okay, so we have FM selected, and that's cut off that line. And the last one we need to check is when we have FM selected, we're going to check this line down through that 2.2K resistor, and that should get to one of the anodes of the ECH85, and we should measure 2.2K. I'm not sure which anode it is, so we'll just check all of them. 2.2K is what we're supposed to get down there. Well, that goes through a coil, so that's near as damn it. That's it. It's working. Let's see if it's not that one as well. 47K. It's that one there. 2.2K it's supposed to be. It's measuring 2.6, but it still goes through a coil. So it looks like that blown or that burnt resistor is actually working quite well. Fantastic. So what have we established? From this point onwards, we know that we can actually paint from there, through the switch, through there, up there, through that resistor, and up to that point over there. We also know that we've checked this here, so from here to there, to that crusty resistor, we know that that's going in there. But what I want to do is I'm going to have to change that resistor anyway. You can't leave a resistor like that in there, which means I'm going to leave this checking for now. I know that it's not open or shorted, and I'll get to the FM section a little bit later. But that has allowed us to do one hell of a lot. As you can see, we've now painted quite a bit of the schematic. We've basically checked, unless I've made some mistake here, we've basically checked the entire B2 plus or B plus lines, going from the start there, from that resistor, and all the way to where it's supposed to go. Now bear in mind, we haven't measured voltages at these points. We can do that later once we power it up. But at least we know B plus is getting to these points, and that makes it a lot easier to move forward. And now moving forward is going to be, again, in steps. That's the way I like it. I'm going to do the power amp section. In other words, what I need to do is check from here, from the pickup input, going into there, into the preamp, into the power amp, and out the transformer. So what we need to do is I'm going to now move on to checking that the audio section is working correctly before I go to the radio section. And we have already established that when I select pickup, the TA, this point here gets switched off. In other words, there's no B+ going to these tubes. I can actually power it up without these tubes. I'll only put in the EABC 80 because I need its triode over there. And I will put in the EL84 because I need it in there. But before that, I need to do some more checking of capacitors. I have to now start on the more critical part of this, which is the capacitor checks. And more specifically, one particular capacitor to avoid major damage. It's that guy over there. That one over there is the one that brings the signal from the anode of the EABC 80, the preamp. The preamplified signal goes in there through that capacitor, 22 nanofarad, I believe it is, right? Yeah. In there, and it takes it to the grid of the EL84. So if I have this thing leaking, my biasing of the EL84 goes haywire because this EL84 is cathode biased, meaning it has a resistor from the cathode to ground. There it is there, 150 ohms. We can check that as well. 50 microfarad capacitor, bypass cap. So that's what I'm going to focus on next, the audio section. And once we have the audio section, we can actually test this whole thing, for audio at least. All right. I think I'll stop there for now and finish off this particular video and look forward to seeing you back again. Bye for now.